The Earth does not easily yield its secrets. Yet around the world, scientists are unraveling the compelling story of human evolution. It is a saga that blends the rigors of science with the romance of a detective story. We have only traces that hint at who our ancestors were and how they may have lived. It is like a gigantic puzzle with most of the pieces forever missing. Today, biological scientists may quibble over the details of evolution, but they all agree that evolution is a fact. Animal studies now shed light on why some distant ape-like creature became an upright walker, and how it may have confronted the perils of life on open ground. Once barely noticeable on the landscape, humans would come to dominate the Earth. The tool, mother of all inventions, was a key to our success. Tools chipped from stone helped bring us to where we are today. Now new tools help us better understand what paths we may have traveled along the way. Much of our current knowledge, our understanding of who we are and where we came from, has come about only in the last 30 years. Can we reconstruct the past? Can long silent voices be summoned across the vast reaches of time? Join us as we probe the mysteries of mankind. By nature, mammals are intensely curious. We humans are the most curious of all, and perhaps nothing arouses our curiosity more than the intriguing question of our origins.
Well, I bet the cavemen's.
Cavemen? What do you think he is?
A caveman.
At the close of the 16th century, when William Shakespeare wrote, "All the world's a stage, and all the men and women merely players," no one had any concept of the vast array of players who preceded us. Today, we yearn to know just who the actors were in this greatest of dramas. When did they appear on the stage? And when did they finally depart? The story is elusive at best, like peering into mists that float above an unfamiliar land. Here and there, through a dusky veil, we think we catch a fleeting echo of some distant call. Feel primordial eyes watching us across the ancestral dark. A thread of kinship surges within us. Then, just as we grasp at a clue, the phantom voices melt away. In the early 1900s, the scientific world believed that the cradle of mankind was in Asia. Then, in 1924, South African anatomist Raymond Dart was brought a skull workmen had found in a limestone quarry. Dart outraged the scientific community by announcing that this primitive, ape-like child was a hominid, a member of the family of man. And he said it had walked upright, just as we do. Dart named the species Australopithecus africanus, southern ape of Africa. For more than a decade, Dart's only vocal supporter was paleontologist Robert Broom. Dart was finally vindicated when Broom, in the 1930s and 40s, discovered an assortment of adult Australopithecine fossils. Africa's Great Rift Valley has been geologically active for millions of years, an ideal setting for the burial of fossils and their later re-exposure. Here, Olduvai Gorge would become known as the Grand Canyon of evolution because of two maverick scientists. Coming here in the 1930s, Louis Leakey and his wife Mary undertook one of the most persistent efforts in the history of anthropology. What particularly excited the Leakeys about Olduvai was the presence of primitive stone tools scattered across the eroded landscape. Their passionate dream, to find the remains of the creatures who fashioned these tools, to find the earliest known human. It would be nearly a quarter of a century before their single-minded perseverance finally paid off. The year was 1959.
We appeared to have got what we were looking for. Here at last was a man or a man-like creature, apparently the earliest known man in the world.
It would turn out to be a teenaged male, and not a true human, but a more primitive hominid, an Australopithecine. And yet surely, like us, he had cried when hungry as a baby, wobbled his way onto two upright legs, knew pain, love, and joy. Then, in the way of all flesh, he died. The boy died near the edge of what was then a lake. The skeleton is missing, perhaps washed away or destroyed by scavengers. Fortunately, the skull was buried by sediments. Over the centuries, water-soluble minerals turned bone to stone as layer upon layer of deposits buried the skull ever deeper into the earth. Some layers were volcanic ash laid down when a nearby volcano erupted. Gradual geological uplift, typical of the Rift Valley, and subsequent erosion brought the fossil once again to the surface. The odds of finding a hominid fossil are said to be 1 in 10 million. Because the Leakey's fossil was found in a deposit with volcanic ash, it could be accurately dated. Volcanic ash contains radioactive potassium that decays into argon gas at a known rate over time. Human evolution was then believed to begin no more than 1 million years ago. Yet here was a fossil nearly double that age. The scientific world was stunned. Today, the addition of lasers to the dating technique enables scientists to date minuscule samples even more accurately. A single grain of ash, seen magnified here many thousands of times, can produce a date much more reliable than ever before possible. The name and age of a fossil tell little about how the creature actually lived, but perhaps the behavior of living primates can. Charles Darwin wrote that we are most closely related to the African apes, but at that time no one knew how closely or to which species. The answer would come from a most unlikely source, the test tubes of molecular biologists. 20 years ago, Dr. Vincent Sarich and his colleagues at the University of California were among a small group of scientists dating evolution with molecules and test tubes instead of fossils. Sarich's group compared a blood protein in 13 species of primates, including humans, and charted when each had diverged from a common ancestor. The dates differed radically from those obtained from fossils. Among the great apes, beginning millions of years ago, the line that led to orangutans was the first to split off from a common ancestor. The evidence suggests gorillas were next. According to Sarich, chimpanzees and man may have diverged as recently as 4 to 5 million years ago. Such a recent divergence was almost impossible for many scientists to accept. Laymen were equally reluctant to listen.
There is still a very strong resistance to looking at human beings in an evolutionary context, especially behaviorally, because we want to retain a separateness. We don't want to see ourselves as having any non-human in our ancestry.
There are significant differences between us. We are essentially hairless.
Oh, he likes the beard.
We are habitually upright walkers. We have a much larger brain, and we have the gift of spoken language. But genetically, humans and chimpanzees are 99% identical. Chimps may even be more closely related to us than they are to gorillas.
Boy.
In 1960, Louis Leakey, with uncanny intuition, sent a young woman into the field to study chimpanzees. Jane Goodall's 27-year-old study has become a classic and confirms Leakey's conviction that chimps have much to teach us about the behavior of early humans.
Understanding of chimp behavior today helps us to understand the way in which our early ancestors may have lived. Because I think it makes sense to say any behavior shared by the modern chimpanzee and the modern human was probably present in the common ancestor. And if it was present in the common ancestor, therefore in early man.
A mechanical leopard was instrumental in an experiment with chimpanzees conducted by scientists from the University of Amsterdam. Anthropologists have long puzzled over how our ancestors defended themselves against predators. How could such small creatures, not yet intelligent enough to make stone weapons, have possibly survived? Leopards are natural predators of chimpanzees. Here, as the chimps attack, we catch a glimpse of how our ancestors, having left the safety of the trees, may have first met the challenges of life on the ground. Once the leopard is decapitated, the chimp may not comprehend that it is dead, but it clearly knows the enemy is no longer a threat. If a chimpanzee has the intelligence to defend itself with natural weapons, it seems likely our early ancestors did the same. The chimpanzee has never become an habitual upright walker. Why did we? Upright walking is so fundamental we seldom think about it, and yet it is one of the crucial ways we are set apart from all other mammals on Earth. When did our ancestors take that first tentative step out of the trees to brave the vast African landscapes? Important answers would be found in the Afar Triangle region of Ethiopia. Here, in 1974, an international expedition of 15 specialists headed out to the remote badlands known as Hadar. Co-leader of the team, Dr. Donald Johansson, describes himself as superstitious. After 2 frustrating months on the sun-scorched slopes, he woke up one morning feeling lucky, and so noted in his diary. Later that very day, the team discovered bones that made headlines around the world. At the time, the oldest, most complete hominid ever found. To anthropologists who usually consider themselves lucky to recover a tooth or a broken fragment of bone, this 40% complete skeleton was a bonanza. Nicknamed Lucy, she quickly became the object of intense study.
What is most exceptional about a skeleton as complete as Lucy is all of the information that we as anthropologists can glean from a skeleton like this. For example, looking at her femur or her thigh bone, which is only about 12 inches in length, we know that she was no taller than 3.5 or 4 feet. Now that brings up the question of, well, was it perhaps a child? If we look at the state of development, for example, of the third molar or the wisdom tooth, is fully erupted and is already beginning to wear. so that relative to modern humans, she was an adult when she died. We're able to tell from the weight-bearing area of the hip socket, for example, she probably only weighed about 50 or 55 pounds. From the size of the brain case, there is enough of the brain case preserved to suggest to us that the brain was very small, about 1/4 the size of a modern human brain.
Historically, large brains have been considered the fundamental human trait. In the 20s, when Raymond Dart suggested a small-brained creature walked upright, he had only a skull to work with. Here was a significant portion of a skeleton, a creature with some very ape-like features that walked upright. Lucy had an ape-like brain, a human-like skeleton, and teeth both ape and human-like, a startling mixture of traits, yet clearly she was a hominid, a member of the family of man. Returning to Hadar the following year, the team combed the slopes, hoping to discover newly exposed fossils. They never dreamed they would find anything as exciting as Lucy. But the Johansen luck proved even better than the year before.
We have the femur and the foot and the knee.
They had come across the first fragments of 13 individuals, possibly members of the same band. They may have all perished together, perhaps in a flash flood. The fossils from Hadar and similar ones from Tanzania represent 35 to 65 individuals. Based on the abundant evidence, Johansen and his colleagues felt confident in announcing an entirely new species. They called it Australopithecus afarensis and put forth the still controversial idea that it is the common ancestor to other Australopithecines who eventually died out, as well as the line that led to true humans. In the laboratory, fragments of skulls and jaws from several males were combined into a composite plaster skull by Johansen's colleague, Dr. Tim White. After initial discovery and analysis, scientists rarely work with an original fragile fossil. In fact, the fossils are usually returned to the country where they were found, but these durable casts are exact replicas down to the most minute details. In Alexandria, Virginia, the composite skull begins a magical transformation in the hands of anthropologist turned artist, John Gurche. Gurche has been fascinated with human evolution since childhood. Today, he combines the talents of an anatomist with those of a master sculptor. His workroom is a cross between an artist's studio and a scientific laboratory.
Placing the eyes is often a special moment. I base the position of the eyes on scientific data, but there's often a mystical side of it as well. That is often the moment where I begin to feel that I'm being watched by the thing I'm working on, that it is not so much a thing of clay and plaster, but is actually a living being. What I really want to do is get at the human past, and having the scientific data behind me makes it much more rewarding for me, because I can believe in what I'm doing. I can believe that the face that's developing in front of me is very much like the face of the individual that it actually belonged to. The really fascinating thing about working with Australopithecines is that you have something that's right on the line between being human and not human. You have a lot of features that are ape-like, and yet it's in the process of becoming human.
The reconstruction will take Gurche more than 2 months. It is painstaking, arduous work that often continues well into the night.
I'd really like to be able to make the claim for this kind of work that it's a hard science. Unfortunately, it's not. It's as good as it can be without actually going back in time and coming face to face with our ancestors. The end result is often a surprise even to me. I'm basing the restoration on clues, one by one, that I'm getting from the bony anatomy, and the cumulative effect of those clues is often a surprise.
A face long lost to the tides of time emerges out of plaster and clay. We come face to face with one of our earliest known relatives, across a chasm of 3 million years. More than 500,000 years before Lucy, and more than 1,000 miles away, a volcano erupted, spewing ash across Tanzania's Serengeti Plain. Then, a moment was frozen in time. An amazing sequence of chance events created a record unique in the pageant of prehistory. Soon after the eruption, the rain clouds that had been threatening parted. Then 3 hominids, perhaps of the same species as Lucy, walked by. Their footprints left an impression in the dampened ashfall. Only because the sun then came out did the footprints harden, and only because continued eruptions laid down yet other layers of ash were the traces entombed for more than 3.5 million years. Today, this area, not far from Olduvai Gorge in northern Tanzania, is called Laetoli. Here, in 1978, a team led by Dr. Mary Leakey finds what is one of the most astounding archaeological discoveries of all time: the very footprints not seen on this earth since the eruption of one volcano millions of years ago. Dr. Leakey and her team begin the delicate process of removing the cement-hard rock. To Dr. Leakey, the prints are more evocative than any fossil. They tell a vivid story of one fleeting moment in time.
The track of footprints that you see here on my left was a truly remarkable find that we made this season. It's a trail left by 3 people who walked across a flat expanse of volcanic ash 3.5 million years ago. We can say they were relatively short. We can estimate that their height was probably between 4 and 5 feet. We can say they had this free-striding walk. One assumes that they were perhaps holding hands, or they're so evenly spaced, the tracks, and they're keeping step, always left foot for left foot and right foot for right foot, that it may, for all we know, have been a family party.
The emotional impact of the footprints is universal, but scientifically they arouse debate. Were these creatures related to Lucy? And could their upright walk so long ago have been the same as ours today? Tim White helped excavate the Laetoli footprints. Now, to answer some of the questions raised, he has devised an experiment. With our closest living relative, he walks across an expanse of wet sand. Its consistency is roughly the same as damp volcanic ash.
Here we have my footprint with a strong heel strike and the big toe in line with the other toes. The chimpanzee's footprint is here and the knuckle print's right behind it. We see the chimpanzee's toe is divergent, whereas the human toe is in line with the other toes. The human foot also has a dramatic arch to it. The chimpanzee foot and its print lacks this arch. And at Laetoli, we have evidence from 3.5 million years ago of a large toe in line with the rest of the toes and a longitudinal arch and a strong heel strike. In other words, the human pattern has been established 3.5 million years ago in Tanzania with these early hominids.
Some scientists feel that only by studying the locomotion of apes can we know how Lucy and our other early ancestors actually walked. At the State University of New York at Stony Brook, a team led by anatomists Randall Sussman and Jack Stern videotapes the movements of an orangutan. They have also extensively studied chimpanzees.
Come on.
Electrodes implanted in the arm and leg muscles send signals to monitoring equipment. Clothing holds the transmitter in place on the animal's back.
That's good bipedalism, Bill. Keep them going.
On their screen, Sussman and Stern receive a superimposed image of the electrical output of the muscles as the animal moves. One intriguing finding: the hip muscles used by apes in climbing are used in many of the same ways as human hip muscles are in walking. So the transition from tree dweller to ground walker may have been relatively simple. The pattern of muscle usage was already in place.
Good boy.
But Sussman and Stern, unlike Johansen, White, and others, believe that these ancestors did not walk exactly as we do, but more like an ape when it walks on two legs. They maintain that those creatures, like apes, still spent much time in the trees and had not yet fully adapted to life on the ground. In earlier days, anthropologists compared and contrasted stones and bones, but could only ponder questions about behavior. Today, they can directly address some of the fundamental issues of our ancestry. How did Lucy and the others live? Where did they sleep? What did they eat? In the line of other Australopithecines to which Lucy may have given rise, there were smaller creatures known as graciles, and robust ones with puzzlingly massive jaws and teeth. The fossil teeth themselves hold clues to what these hominids were eating. Thousands or millions of years later, the wear on the teeth remains.
Let's see if we can acquire that image.
Dr. Fred Grine, also at Stony Brook, studies diet using a scanning electron microscope and computer graphics. Different foods leave distinctively different marks on teeth.
Comparing the two patterns of a gracile and robust Australopithecine side by side becomes quite evident that the wear patterns are very dissimilar, and that therefore the foods that they would have eaten would have been dissimilar. The scratches and the polished surfaces found on a gracile Australopithecine molar would have been produced by soft foods such as soft fruits and leaves, whereas the pitting, which characterizes a robust Australopithecine molar, would have been produced by hard food objects such as seeds and nuts.
Shrouded in myth since their discovery, Australopithecines were long characterized as bloodthirsty killer apes. It now seems far more likely they were vegetarians who should be seen in their more rightful place in the human evolutionary drama. Robust Australopithecines flourished for well over 1 million years, then disappeared, an apparent evolutionary dead end. It is possible they lost out in competition with another, more intelligent species, a hominid tool user, a line that would eventually lead to modern human beings. Like the remains of their predecessors, the fossil bones of the tool users are almost always discovered in deposits formed along lake shores or streams. The areas around Lake Turkana in northern Kenya have a record of both human and animal life that is perhaps unmatched in the world. Every week during the field season, a light plane from Nairobi brings expedition leader Richard Leakey, son of Lewis and Mary Leakey. Despite an early decision not to follow in his parents' footsteps, Richard's passion for paleontology won out. For 2 decades, he has been digging here with remarkable success. Over the years, since 1968, the Turkana region has yielded 10 to 15,000 fossil remains. Most are animal, but amazingly more than 300 are early human. Leakey has been called the organizing genius of modern paleontology. He heads a team that scours the exposures daily for several months at a time. They cover every foot of the 600 square mile area each year.
Looking for new evidence in any scientific discipline is exciting. In our field, it's particularly rewarding because every year there's a new opportunity. These vast areas of desert are periodically washed by rain, and every time it rains, there's a chance that something new will be exposed. There's something new that's going to tell us something we never knew before. It's going to expose a completely new chapter in our understanding of human origins. And it's really great fun to be out there on the desert, realizing that although you were there the year before, this year it'll be different because it rained a few months ago and something new must have washed up somewhere. It's simply a question of finding it.
In 1984, a small piece of skull was found. It was immediately recognized as human by Leakey's colleague, Kamoya Kameyu. With anatomist Alan Walker and the rest of the team, he went on to unearth a seemingly endless array of bones. The rest of the skull and face were found, and painstakingly glued together from 70 separate pieces. The bones were clearly those of a Homo erectus, a species on the path that eventually led to modern humans. The skeleton, a boy of about 12, was dated at more than 1.5 million years old. Far more complete than even Lucy, it is one of the most remarkable finds in the study of human evolution. The boy differs little from a modern human in stature and body proportions. An artist imagines what he might have looked like. Richard Leakey reconstructs what his life may have been like.
The area that he was living in was probably lake margin, swampy ground near the lake edge. There was grassland, there were forests, there were permanent rivers running into the lake. Probably an enormous amount of animals, plains animals, carnivores, scavengers. I suppose one could visualize an area like one of the better national parks in East Africa today, teeming with wildlife, ideal conditions for an early human. I think it's remarkable because it's so complete, but perhaps another aspect that is often overlooked is that many people who don't like the idea of human evolution have been able to discount much of the work we've done on the basis that it's built on fragmentary evidence, that they've just been bits and pieces, and who knows, those little bits of bone could belong to anything. To confront some of these people with a complete skeleton that is so manifestly human and is so obviously related to us, in a context where it's definitely 1.5 million years or a little more, is fairly convincing evidence. And I think many of the people who are fence sitters on this discussion about creationism versus evolution are going to have to get off the fence in the light of this discovery.
A Homo erectus head would have looked very different from our own. It had a heavy brow ridge, jutting face, and smaller brain case. It is very likely their skin was dark, nature's protection against the tropical sun. Some scientists believe Homo erectus was the first hominid to hunt. In earlier times, our ancestors, themselves prey, were probably accepted without fear at Africa's waterholes, but when they began to hunt, the other animals would sense them as a threat. Exactly when hunting began may never be known, but it is clear that the tools made by Erectus were far more sophisticated than any that had been made before. Even the earliest and most primitive tools marked a momentous advance for humankind, the first evidence of culture. And as intelligence grew over time, tools became ever more refined and specialized. Learning how tools may have been made and used provides a window into the behavior of our ancestors. Dr. Nicholas Toth of Indiana University has become a master of the technique. Many scientists had believed that the objective of the earliest tool makers was to create these large cobbles, and that the chipped-off flakes were merely the debris. Toth's experimentation led him to conclude it was quite the reverse. The razor-sharp flakes, he believes, were often the tools our ancestors made and used.
If you take a hard look at your average human being, we're very poor carnivores. We have small canines. We don't have slashing claws. We're not very strong. We don't look anything like a hyena or a lion. And I think with the simplest flakestone technology, you can butcher an animal from the size of a gazelle to the size of an elephant with absolutely no problem.
Even hyenas will not tackle the biggest bones on a carcass. But with the simplest tools, used like a hammer and anvil, an early hominid could get at the marrow inside. Almost completely fat, marrow is high in calories, essential to a hominid roaming the African landscape. When an animal bone is butchered, the edge of the tool leaves cut marks. Often ignored in the past, cut marks are now recognized as vital clues to the behavior of early humans. They can tell us, for instance, which animals our ancestors ate, which parts of these animals they may have favored, and ultimately, they may reveal when hominids became successful hunters. In the past, scientists often suspected cut marks were man-made if tools were found nearby. Today they know many factors from the natural world can plant false clues. One factor not often considered came to light in an unusual experiment conducted by Dr. Kay Berensmeyer. In Asia, she had been puzzled by grooves and scratches on bones 8 to 9 million years old, long before hominids existed. Later, in Africa, she saw how bones frequently are trampled by migrating game herds. Could random trampling, she wondered, leave marks that could be confused with those made purposefully by a tool? Dr. Pat Shipman of Johns Hopkins University has been experimenting with cut marks since 1978. She believes that by creating them herself and examining them microscopically, she and others can better define what is a true cut mark and what is not. Into a scanning electron microscope, or SEM, she inserts a gold-coated cast of the mark she has made. Compared with regular microscopes, the SEM offers greater depth of field to look at three-dimensional structures. It seems likely that marks on bones found in sandy soil may remain open to interpretation. But for others, Shipman has found that what distinguish a true cut mark are the fine lines within a groove. Experimenting, she says, is the best way to suggest what happened to a bone thousands or millions of years ago.
The problem for us today is to tease out of the past, to coax out of the evidence the specialness of early hominids. And once we know where we started and how we started and what was important then, we may have a very different idea of what it is to be human.
Homo erectus was the first human species to leave Africa. Sometime after 1 million years ago, their fossil remains and those of a number of African mammals first appear in other tropical regions of the world. Some scientists believe that by then meat had become an appreciable part of the diet. With the addition of this important protein, this intelligent and curious creature would have been well equipped to expand out to unknown lands. We know from preserved remains and tools that Erectus reached China, Java, and southern Europe. On the Sussex coast of England, quarry workers were the first to unearth a site called Boxgrove. It may hold answers to the lifestyle of the species that came after Homo erectus. About 350,000 years old, Boxgrove is an unusually important site. It covers 100 acres, and it contains vast numbers of tools and animal bones that are extraordinarily well preserved. Erectus probably never reached this far north in Europe, but his descendants did. They were the earliest form of our own species, Homo sapiens. Here, flags mark the locations where their tools or fragments have been found. Animal bones abound. Deer teeth, part of the lower jaw of an extinct bear, a large pelvic bone with cut marks that hint at a tool user's presence. Yet, strangely, no human remains have been found. So untouched is the site that if one could peer back through the centuries, here would sit an ancestor chipping stone to make a tool. Nearby, what may have been that very tool is held again in a human hand, for the first time in 350,000 years. Perhaps it was used to scrape wood, prepare a hide, or dig for roots in the ground. It may have helped kill the deer or bring down the bear. But where is the maker of the tool? Once Boxgrove was a beachfront, ideal for the preservation of fossils. Why no people have been found remains just another missing piece in the human puzzle. These pre-modern Homo sapiens seemingly evolved from Homo erectus, but their exact relationship to erectus, as well as to the more modern humans who followed, is still unclear. One of the most puzzling of these pre-modern Homo sapiens was Neanderthal. Some scientists think they were a short-lived side branch on the family tree. Indeed, the longest ongoing controversy in paleoanthropology has been, who were the Neanderthals? But there are more questions than answers. We do know the Neanderthals were not the dim-witted brutes so often portrayed by cartoonists, but one characteristic attributed to them is true. They were cave people. At Kebara Cave in Israel, a Neanderthal excavation is run jointly by Israeli and French teams. When carefully studied, layers in a cave can tell a rich story. Too often in the past, they were dug with reckless abandon. 30 years ago, Kebara was attacked with pickaxe and shovel. Today, dental probes and fine brushes move methodically, inch by inch. Each pail of dirt is screened for even the tiniest fragment of bone or stone. Each piece will then be washed, identified, labeled, and cataloged. By far the greatest number of finds at Kebara have been these well-fashioned tools. Literally hundreds of thousands have been unearthed. The leader of the Israeli team is Professor Ofer Bar Yosef. He has clear evidence that over many thousands of years, Neanderthals repeatedly occupied Kebara Cave.
What we can see here are the fireplaces as built by the people around 46,000 years ago. And this is one of the special features of Kebara Cave, that we can see these fireplaces which are built one on top of the other and always at the same place in the central area of the cave. They were either heating the area of the cave during winter time or also using them for cooking. And then when you still have the hot ashes, spreading them so they can sleep on them. One problem that we should always keep in mind is that we cannot and we should not perhaps excavate the entire cave area because we have to preserve part of it for future archaeologists who will probably use better techniques of excavations or better approaches. And therefore, we'll never know the entire picture of what really happened everywhere.
We do know Neanderthals camped in this natural shelter, or at least came here with food, perhaps huddling in groups around the warmth of a fire. We also know some of them died here. Neanderthals were the first people to bury their dead. This skeleton, except for the missing skull, which may have been used in some ritual, is among the most complete Neanderthals ever found. What the meaning of burials was in the life of these long-vanished ancestors cannot be known for certain, but the fact that they buried their dead links them to us in deep and meaningful ways. From Neanderthal excavations throughout Europe and the Middle East, a picture of how they lived has gradually emerged. Theirs was a non-settled existence. A socially organized people, they traveled in groups as they moved from place to place in search of food. Hardy and robust, they were probably much stronger than most modern people. They survived even in harsh Ice Age conditions. Whether they had language as we know it is unclear, but surely, in some sophisticated way, they communicated with their own. Then, about 30 to 40,000 years ago, these intelligent, well-adapted people mysteriously disappeared. They may or may not have evolved into modern Homo sapiens. If modern Homo sapiens evolved elsewhere and then migrated, Neanderthals may have simply lost out to them. Anatomically much like us, these early modern humans stood at the threshold of everything we usually define as human. Farming and the rise of great cities would await a later time. But these early modern humans were the very first to create fine art. This rich record of the past ranks among the greatest artistic achievements of humankind. We know these people spread to every habitable part of the globe. But where had they come from? One scientist at the British Museum of Natural History in London thinks the answer has been found. Physical anthropologist Dr. Chris Stringer.
The research on the origin of modern people is interesting, obviously, because it deals with the origins of all living people alive today. And my idea of an African origin is based partly on the fossil evidence. I feel that modern people appeared earliest in Africa and then later on in other parts of the world. But there is also genetic data, and the genetic data also support the idea of an African origin of modern people.
At the University of Hawaii, one of the primary genetic researchers in this field investigates the migration patterns of modern races. Dr. Becky Can believes her research adds rather startling information to the theory of an African origin.
All humans who are alive today can trace their ancestry and their genes back to a single female who we think lived in Africa sometime perhaps 200,000 years ago.
Dr. Can bases her theory on studies of DNA extracted from women. She traces backward in time one part of the DNA molecule that only females can pass on. The genetic work is supplemented with interviews about the women's maternal ancestry.
Could I ask you about your maternal grandmother, your mother's mother?
My grandmother was born in August 10th, 1903, in Macau, which is a small colony off the coast of China.
Dr. Can has studied Americans of European, African, and Asian descent, as well as Australian Aborigines. By comparing small segments of DNA from these women, Dr. Can assesses the similarities and the differences. The more alike the DNA, the more closely related two individuals are. With a computer, Can suggests different migration patterns over the centuries. If she is right, modern humans, like earlier hominids, evolved in Africa.
In Africa, it seems that the evolution of modern people first began, and from there, we all trace our ancestry. So we're all very closely related. And that goes for people, American Indians, Australian Aborigines, Eskimos, Europeans. We all trace our origin to Africa, and under the skin, we are all Africans.
Old concepts of human diversity die hard, but certainly we must consider the possibility that human equality is a fact of our evolution, that it's in our very genes. We are all time travelers together, the most recent players in a drama that began at least 4 million years ago. In the detective story of human evolution, we know in a broad sense how the plot turned out, but we know very little about the chapters along the way. There are too many fossils that are merely fragments, and too many gaps in time for which we have no fossils at all. The science of anthropology is little more than 100 years old, but as it moves forward, it opens new mysteries, poses greater riddles. To begin filling in the numerous blanks, the discovery of new fossils is essential. New technologies will add other pieces to the expanding puzzle. But that is all we can expect, random puzzle pieces. Never can the entire picture be known. For scientists, the excitement of the quest never diminishes. And as the rains come again next year and the next, they know that somewhere in thousands of square miles, with a bit of luck, they will find new and even more provocative clues to the ongoing drama of our human past.